My grandmother, Dorothy Skillman Bishop, was a high school biology teacher. She elected a path of teaching instead of working at the family grocery store. One of her proudest moments was when her former student went to work in Oak Ridge. I just want to take a moment to thank my grandmother who fostered my love of science. Thank you all in your role as educators for inspiring so many to learn. I greatly appreciate all of you and make sure to thank all those educators from your life that inspired you. Today I feel I have the best job in the world. I'm a scientist that studies scientists. I also want to take a moment to thank the University and State of Tennessee for supporting a research and teaching agenda focused on saving the world one file at a time. Although there aren't rainbows every day on campus, it is an amazing place to work. Research data management, what I do, entails appraising, preserving, storing, and transforming digital objects to enable reuse. Gradually, research institutions and funding agencies across the globe have incentivized and mandated data sharing through data management plans, DMPs, as a way of supporting a more open and data-intensive research enterprise. As AI, and specifically machine learning, progresses, the need to understand how humans discover and evaluate science data grows in importance so that we can build those heuristics gained from years of experience into our tools and artificial research assistants. That's an image of Dr. Carolyn Hank translating my writing into English and a few best papers. Thanks, Carolyn. Today we are working to determine whether life and all its assorted data will be as open as possible and as fair as necessary. But what's fair? In response to the need in many sciences for machine actionable data, Force 11 created the FAIR data principles. The 15 data principles are around 4 broad categories: findable, accessible, interoperable, and reusable. This study's purpose is to understand the discovery and curation behaviors of managers of physical collections to improve their organization, access, and use. I must thank all the librarians, curators, collection managers, and others that have participated in my studies over the years. Physical collections present their own unique challenges to making their data fair. The large investments of public funds being made to curate huge volumes of samples acquired and stored over decades and indeed centuries call for these collections to be as open as possible, easily discoverable, and well documented. The state of sample data management in the US and globally is highly fragmented across many stakeholders, including museums, federal agencies, academic institutions, and individual researchers, with a multitude of institutional and discipline-specific catalogs and repositories. This study uses past valid methodology of data curation profiling to capture all actions across the data lifecycle. Propulsive recruitment occurred through personal contacts in scientific communities. Although more work needs to be done, my graduate research assistants, Sid Gavel, Emily Chapin, and I have transcribed, coded, and are ready to share some preliminary findings from the first 4 focus groups. Participants were asked to each give an overview of the collection they managed, including the size of the objects, the storage approaches, and the tools used to organize data. Focus groups also addressed how the collection was organized, what metadata were reused, persistent identifiers, and ultimately, how the stuff is found and used. The volume and variety of these objects was best summarized by a participant from the Paleo Collections group. We covered the entire fossil record, from microfossils, which are microscopic in scale, all the way up to dinosaurs and whales. The scope for any of these collections mirror the complexity of each research area. Whether osteological human collections or 2-mile-long ice core, each physical research object presents its own unique accession and storage issues. This is my daughter Anna with the oversized specimen FMNH PR 2081, which goes on display because it can't fit in storage. Although it'd be tough to lose a T-Rex, curating millions of other physical specimens requires more nuanced organization and unique identifiers to distinguish things held in tons of drawers and boxes. These are all my daughters with another specimen, BHI 3033. Naming conventions are usually something very simple, like these alphanumeric T-Rex examples, but the goal of many managers now is to assign IGSNs, or possibly DOIs. The International Geosample Number is designed to provide an unambiguous, globally unique, persistent identifier for physical samples. The National Museum of Finland recently returned the human remains of its Mesa Verde archaeological collection to representatives of the indigenous peoples. Repatriation of human remains is guided by international and federal law, but some participants were working with some source communities to know what's okay and not okay for all kinds of other collection objects. Storage in cabinets, racks, pallets, condensed shelving, lots of fish, all work with long-term preservation, but to enable data discovery, a searchable database is required. For biocollections, tools like Specify help capture and organize all the objects related to a specimen, like photos, DNA, field notes, maps, 3D models, CT scans, and more. Legacy data is a broad term for all types of past work not done to today's data collection standards. Interestingly, analog researchers sometimes took more detailed information about the context beyond a simple GPS point to help inform future study. As one participant put it, the next generation will be like, why the heck weren't they collecting this data piece? So we always moving forward. In a fair research data landscape, today's items missing metadata elements will be seen in this same way. Legacy data with limitations for reuse and not at all machine actionable. For these collection managers, reuse is essential, and FAIR is a roadmap to get our collections there. One participant said, we're constantly trying to prove our purpose and existence on campus, and getting people to research and publish our specimens is the #1 way to do that. Increasingly, researchers do not have the physical capability or funding to view physical objects and need digitized collections. A participant from the Geologic Core group said, it's a lot like a library. We may not be able to see the entire world in a bean quite yet, but through the work of many, we're getting there.